Other forms of the logistic equation. Again, we've seen that the form y prime equals ry times 1 minus y over L is a common form, and the function doesn't have to be y. It could be x, it could be p, it could be n, p for population, or n for number. Just a quick search of the web. The first 5 forms that I encountered there. P prime equals RP times 1 minus P over L, which is simply equivalent to this form, and I believe is close to the form given in your text, in one of your texts. As a matter of fact, I think that one would be P prime equals RP times 1 minus P over P sub L, where P sub L is regarded to be the limiting population at the limit. There are many ways to express this kind of relationship, and this looks like the same as this because I think I intended to write this one here. P prime equals P times, that's supposed to be 1 minus P, and I'm cheating by putting a piece of paper in there because I got a little early with my negative sign. This is a case that you would get when you rescale your P variable so that the population limit is 1, which means essentially that the population limit would be equal to your carrying capacity, so that when you reach your carrying capacity, your population is 1 carrying capacity, so that the units in which your population would be expressed would be multiples of the carrying capacity. We're not going to get too far into that, but that's a very common and very simple form of the equation, and the variable can then be rescaled to any carrying capacity, any time scale you wish. Another form I've seen is P prime equals RP times 1 minus P over K. Now this is a capital K. It's nothing like the K that I used, which was out here. You see the K here. Another form I've seen is N prime equals R times N times K minus N divided by K. If you divide this through by K, you get 1 minus N over K, which would be pretty much identical to this form, except we're using N instead of P. So my point is that there are a large number of ways of writing the logistic equation. You don't want to be dependent on just one way, and every one of these equations can be easily solved by separating the variables and applying initial conditions.